Hi class, we need to take a look at example 2. Now, example 2 for the problems they're asking for a couple of items, in this case, the domain, the range, and if the function is 1 to 1. Now remember that the domain is your x values, your range is the y values, and if the graph is 1 to 1, it passes the horizontal line test. So let me just move the actual the file to the top so we can look at the definitions. And when we're looking for one-to-one functions, we're looking within the set of functions. So for the vertical line test, which is here, we're determining if the mathematical structure is defined as a function, which means every x value has a y value. If an x value has multiple y values, it's not going to be a function. Now, for the horizontal line test, these already have been defined as functions, and what we're looking for is a horizontal line that if it touches at 2 points, then in that case it's not going to be a function. The idea is that if you were to flip all the coordinates, and basically your x becomes your y, an x value is going to have 2 intersections. So it deals with functions that you can find the inverse. At the moment, we're just looking at the idea of one-to-one, which is a property that it's needed for a later portion of the course. Okay, so let's first take a look at the actual idea of the domain. So when we talk about the domain, we're going to be looking at your x values. Now notice that there's no x values on the left of 0. So this one's going to start at 0 and then it's going to go all the way to the positive infinity. So because of the arrow going to the bottom, 0 is not included. So we would typically say 0 to the values of positive infinity. We're not including 0. That means that we're including all of these values for your x's. Next would be the range. The range, you're going to be looking at your y values. In this case, we'll notice that your y's go all the way to the negative infinity, all the way to the positive infinity. So all the y values, or in this case for negative infinity to positive infinity. And then the last portion is the one-to-one. Now for the one-to-one idea, we typically just insert a horizontal line. And let me try to insert the tools here. And we just show that, well, the horizontal line has to be dotted since technically is not part of the line or is not a solid line. And then we typically just provide a single dot as the intersection. Oh, that one's a little bit too large. Hold on, let me make it smaller. And that shows that wherever you move this horizontal line up or down, you're only gonna have a single intersection. What you cannot have is, like the definition states up here, that if you draw the horizontal line, you have 2 intersections. In this case, this function is not one-to-one. The horizontal line test intersects twice. So you would simply say, in this case, that the function is one-to-one. It passes the horizontal line test. So let me just write it out. Yes. The function is one-to-one because it passes the horizontal line test. And that's actually it for our answer for the first problem, or problem 1. So we're looking at domain and range, and then also if it's one-to-one. In this case, this function is in fact one-to-one. Let's move on to problem 2. In problem 2, we're just getting a piece, and in this case, let me start with the domain. And notice that your domain, it's going to represent your x values. So you're looking at all your x's, in this case from here to, well, in this case, including 4, but not including 8. So bracket 4 to 8 along your x's. The range, we're going to be looking at your y values. And our y values are going to start after 2 all the way to 8. So not including 2 and 8, we are including it. So once again, from 2 to 8 and from 4 to 8. And on the domain, we're not including 8 because of the open circle. And on the range, we're not including 2. So this coordinate point of 8, 2 is not included. The next portion, it's going to be with the horizontal. This one, yes, it's going to pass. Let me just draw the actual line. And then the intersection. In this case, that would be our intersection. And then we'll simply say for the one-to-one portion, yes, the function is one-to-one. Because the function passes the horizontal line test. And that's actually it for this one. And it looks a little bit tricky once more for the domain. You're going to be including 4, not 8. And then on the range on your y's, 2. And you are including 8, but 8 here represents your actual y value. Let's take a look at one more. In this case, notice that we're going to have 2 intersections. So let me write this one first in terms of the domain. So the domain, it's going to be from -4 to 4. We're going to be looking at these x values. Your y values are going to be here. So your y values from 0 to 2. So range from 0 to 2. I notice that we don't have an open circle, so we're going to include 2. And let me include the horizontal line for the horizontal line test. And this one is going to fail, but let me first insert the line. Okay, so let me insert the dots here, and you can see the 2 intersections. the two intersections that we're looking at and that we don't want for one-to-one. So for the portion of one-to-one, we would say no. The function is not one-to-one because the function fails the horizontal line test. And then if they're asking, you would provide the two coordinate points. In this case, it's sufficient to put them on the line. You're basically making a statement of yes, it passes, or no, it fails, and you're including it here. If they mention anything about include coordinate points, then you would say that, well, you technically have x is equal to 2.5, approximately 1, and 2.51, which has two y's. Or in this case, there's two intersections for your y values. That's actually it for these problems. I'll put the rest of them on another video.